This is lecture 7, Introduction to Proofs, and we're in the exercise section. And we completed a proof by contraposition, and we're now ready to do a proof by contradiction. Our proof is prove that if n is an integer and n cubed plus 3 is odd, then n is even using a proof by contradiction. Our first step is to let p be the proposition that n is odd. We know that n squared is odd because the product of two odd integers is odd. We know that n cubed is odd because the product of two integers is odd. We subtract n cubed plus 5 from n squared, or from n cubed, obtaining 5. And we know that 5 is even because the difference of two odd numbers, n cubed plus 5 and n, is even. This is a contradiction. The integer 5 cannot be even and odd simultaneously, hence not p and n is even. Show that at least 10 of any 64 days chosen must fall on the same day of the week. We give a proof by contradiction. If there were 9 or fewer days on each day of the week, this would account for at most 9 times 7 is 63 days. But we chose 64 days. This contradiction shows that at least 10 of the days must be on the same day of the week. Prove that if n is a positive integer, then n is odd if and only if 5n plus 6 is odd. We need to prove two things. Let p be the proposition n is a positive odd integer. Let q be the proposition that 5n plus 6 is a positive integer. Our statement is to prove p if and only if q. We must show that p implies q and q implies p. We will show that n is odd. Show that if n is odd, then 5n plus 6 is odd. P implies q by direct proof. We will show that if 5n plus 6 is odd, then n is odd. Then q implies q by contraposition. That is, we will show not p implies not q. If n is even, then 5n plus 6 is even. First, we will show that if n is odd, then 5n plus 6 is odd. P implies q by direct proof. Step 1. Let n be equal to 2k plus 1, where k is an arbitrary positive integer. This is the definition of the odd integer, and the domain is restricted to positive integers. 2. 5n plus 6 is equal to 5 times 2k plus 1 plus 6. We do that by substitution. We get 5n plus 6 is equal to 10k plus 10 plus 1. 5n plus 6 is equal to 2 times the quantity 5k plus 5 plus 1 by the distributive law of multiplication over addition. We conclude that 5n plus 6 is odd because we have 2 times an arbitrary integer plus 1 by the definition of an odd integer. Now we will show that if 5n plus 6 is odd, then n is odd. Q implies p by contraposition. That is, we will show not p implies not q. If n is even, then 5n plus 6 is even. Let n equal 2k, where k is an arbitrary positive integer. Then we have 5n plus 6 is equal to 10k plus 6. We factor out the 2, and we get to 5n plus 6 is equal to 2 times quantity 5k plus 3. And we know that this is an even integer by the definition of an even integer. And that concludes our lecture.